Welcome, geometry students, to class today on Tuesday the 10th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's look at 4 quick announcements. Number 1, your exam will be next week. I'm not sure of what day, but you should have copies there at the school of the final exam schedule. I will try to have that on tomorrow's announcement, but you can look on the exam schedule and see when your exam is. But again, I should have that up tomorrow for you. Test retakes, you must have them done by Friday. No one's contacted me yet. If you want to do a retake, I got to know by Friday. I got to know pretty much right away, and I've got to know what day you're going to take it and what teacher, and I have to have at least 1 day's notice so I can get all that set up. Okay, Haley, I want to point out to you that I'm well aware of the fact you were not here for the entire first semester, and so you are going to take the entire exam. However, I will grade it fairly and graciously, so study very diligently for the entire exam, and a lot of the stuff you had at Central already, I'm sure, but nonetheless, I will grade your exam fairly. If you do not finish the video in class today, you are to go home and finish the video tonight. And so please keep that in mind. When I say I'm going to do a really quick review of the main thoughts that we talked about yesterday, it's going to be so fast, you're not going to be able to write anything down, and I would encourage you not to. You can always go back later and kind of look all this stuff over on your own, okay? But here we go. Yesterday we looked at the definition of a polygon, what that was, okay? A figure made up by segments that intersect two other segments at its endpoints. Okay, we looked at triangles, quadrilaterals, pentagons, hexagon, heptagon, octagon. I want you to know this is 3-sided, 4-sided, 5-sided, 6-sided, 7-sided, and 8-sided. So you need to be familiar with that. You need to know that the sum of the interior angles of a quadrilateral is 360. You need to know the leg angles of a trapezoid. Here's a trapezoid right here. And not a very good trapezoid, but nonetheless, there's a trapezoid, and this is a leg, and this is a leg. So the leg angles of any trapezoid are supplementary, and the legs are the non-parallel sides. So this angle here and this angle here, they're supplementary. This angle here and this angle here, they're supplementary. The base angles of an isosceles trapezoid are congruent. The bases of a trapezoid are the parallel sides. So again, here's my trapezoid, parallel sides right here. These are called my bases. So if this side here is congruent to this side here, then I have an isosceles trapezoid. I have one set of parallel sides and one set of non-parallel sides, and the non-parallel sides are congruent. Then this angle here is going to be congruent to this angle here, and this angle here will be congruent to this angle here. Number 6, in a parallelogram, both sets of opposite angles are congruent, and consecutive angles, that means side-by-side angles, are supplementary. You need to know the 5 ways to prove that a quadrilateral is a parallelogram. I'm not going to ask you to list those out, but you need to be familiar with those. Both sets of opposite angles are congruent, both sets of opposite sides are congruent, both sets of opposite sides are parallel, the diagonals bisect each other, and one angle must be supplementary to its 2 consecutive angles. You should be familiar with this right here. I'm going to enlarge it and then shrink it back down again. Be familiar with that, okay? Be familiar with this. Know that all of these shapes here are quadrilaterals, and then an isosceles trapezoid is also a trapezoid. A rectangle is also a parallelogram. A square is also a parallelogram, a rectangle, and a rhombus. A rhombus is also a parallelogram. Know all of that, okay? Very important. Very important. All right, number 8, know the formula for the midsegment. Midsegment of a trapezoid, 2ms equals base 1 plus base 2. Number 9, know the definitions of the 6 special quadrilaterals that we studied in this chapter. What are those 6 special quads right here? Parallelogram, trapezoid, isosceles trapezoid, rectangle, square, rhombus. I'm not going to ask you for any definitions or fill in the blanks. However, you still need to know the definitions so you can answer questions about certain problems. Whoa, is that it? Okay, that's it. So there's the review from yesterday. Those are the main thoughts you need to be familiar with. And now if you have test number 1 or test from chapter 1, please get it out. If you don't, that's fine. If you don't, just take some really good notes. I'm going to have all the problems right here in front of you, and so it should not be a problem for you to be able to follow along. So here we go. We looked in chapter 1 at patterns, okay? So for numbers 19 and 20, I want you to write the next figure that you would expect in the pattern. What we're trying to do is look for patterns and predict what would happen next and make a conjecture. We're going to conjecture what the next pattern would be right here. Well, let's see. We had this right here, and then notice we added this row. Let me get a different color of ink. We added this row right here. And then notice we added this row here. And every time we added a row going across, notice the black shaded area went from the left to the right to the left. So, I wonder if I can, well, that whole thing's cut and pasted. Okay, never mind. So, my answer then would be, we know the top stays the same. And then it goes like this, and then it goes like this. So then for the next part, we would just have another row added across the bottom, like this, with this right side over here shaded. So that's the next pattern. And then here we start off with a square, then we draw a diamond inside of the square, then we draw a square inside of the diamond. So then the next figure, I'm going to make a conjecture. Would be putting a diamond inside of a square like this, and then next would be a square inside of a diamond, and then a diamond inside of a square, so on and so forth. So we start off with a square, then a diamond inside, then a square inside, and then a diamond inside. So what do I want you to learn from this right here for your test coming up? I want you to be able to look at certain figures and figure out a pattern, what's going to come next, and make a conjecture or an educated guess based on evidence that you have as to what the next figure will be. Okay? All right, let's continue on. Now for these two numbers here, 21 and 22, you're really doing the next thing, only instead of using pictures like we did here, we're going to use numbers. So you're going to try to figure out what pattern we have, what number is going to come next, and then you're going to make that conjecture as to what the next number will be in this list of numbers. For example, I went from 1 to 5, 5 to 25, 25 to 125. Well, I notice right away I'm multiplying by 5. 1 times 5 gives me 5. 5 times 5 gives me 25. 25 times 5 gives me 125. So the next number would be 125 times 5, which is 625. Now students, listen to me. There's no way I can teach you steps on this. You just have to look at the numbers and figure out the pattern and make a conjecture or an educated guess as to what will come next in the series of numbers. Now number 22, this one's a little harder, but think about it. If I go from 1 to 1, maybe I'm adding 0 over and over. That doesn't make sense. 1 plus 0 is 1, but then 1 plus 0 is not 2. Well, maybe I'm multiplying by 1, but that doesn't make sense. 1 times 1 is 1 times 1 is 1. And then I notice this. I notice the first number here, I multiplied by 1, which gave me a 1. Then I multiplied by 2, and that gave me a 2. Then I multiplied by 3, and that gave me a 6. Do you see the pattern? Then I multiplied 4, that gave me 24. Then I multiplied by 5, that gave me 120. So then I multiplied by 6, and that would give me, of course, 720. Again, there's no way I can teach you steps on this. It's just looking at a random set of numbers and figuring out a pattern that's going on and then making a conjecture as to what the last number will be. Okay? So that's numbers 21 and 22. So on your test, be able to look at picture patterns and number patterns and make a conjecture as to what the next number will be. All right, numbers 23 and 24. I want you to give a counterexample for each conjecture. that proves the conjecture false. Now, we have a statement here, and in order for me to prove this statement wrong, all that I have to do is give one counterexample, and then I can prove this is not right. So let's see. All rectangles with an area of 12 square feet have the same perimeter. All right, let's see. I'm going to draw a rectangle that has a length of 4 and a width of 3. Okay? Then I'm going to draw a rectangle that has a length of 6 and a width of 2. Now, I don't think you would argue with me. 3 times 4 is 12, so the area would be 12. And 6 times 2 is 12, so the area is 12. So notice both of these rectangles have the same what? The same area. Okay? And here's what this sentence states. All rectangles that have an area of 12 also have the same perimeter. So this rectangle has an area of 12. This rectangle has an area of 12. Let's find the perimeter of this first rectangle. This is 4, so this is 4, so this is 3. Add up all sides and you get 14. Now let's find the perimeter of this rectangle right here. Well, if we add up all the sides, we don't get 14, we get 16. So I just proved this wrong. And that's called a counterexample. So on a test or a quiz, this whole group, this whole thing right here would be your answer, okay? Because you're showing me two rectangles that have an area of 12, like this says, but notice their two perimeters are different. And up here it says the perimeters will be the same. So this is a counterexample. Now, number 24. If the sum of two numbers is positive, then the two numbers must both be positive. Now think about that. If the sum of two numbers is positive, then the two numbers you added must both be positive. And that's not right at all. If I have a positive 4 and I add a negative 2, I get out a positive 2. If the sum of two numbers is positive, now I have a question for you. Is the sum of these two numbers, that means I add two numbers together, is the sum of these two numbers giving me out a positive number, yes or no? Yes, it is. If the sum of two numbers is positive, then the two numbers you added must both be positive, and they're not. This is a positive number right here, and this is a negative number right here. So I added a positive and a negative number, and I got out a positive number. And this says if you add two numbers and get out a positive number, then the two numbers you added must both be positive. And that's not true. And here's a counterexample right here. So here's what I'm trying to review. Okay? I want you to be able to look at a statement that I give you and either draw me a picture or show me an equation or do something that gives me a counterexample that proves this wrong. Okay? So be able to give counterexamples that prove a statement wrong. Okay, now let's talk about planes, points, lines, segments, etc. Okay? Question number 25. Name a point that is coplanar with plane Q and K. Now I'm going to take my red pen and I'm going to mark plane Q and K. Here's Q, go up to N, go over to K, and then go down to R, and that's a plane. It's this left side right here of this box. Okay? So there we go. That's the plane. Now here's what it says. Name a point that is coplanar. In other words, name a point that lies in this plane. Well, point R right here. All four of these points lie in this plane. N, K, R, and Q all lie in this plane. So I would say point R. Point R. Next question. Are points L, M, and N collinear? Now, do you remember what collinear means? It means that all of these points lie on the same line. The same line. Well, let's take a look. All right, we're dealing with points L, M, and N. Here's point L. Here's point M. And here's point N. There is no way that those 3 points line up on the same line. Okay? No, they are not collinear. I mean, this line here would continue on and on going this way, and this line here would continue on and on going this way. All 3 of these points, L, M, and N, do not lie on the same line. Thus, those 3 points are not collinear. Number 27, name 3 segments that contain point P. Well, here's point P right here, and let's name 3 segments. Well, this segment right here, a segment would be the same thing as an edge of this cube, okay? Well, QP contains P, SP contains P, and MP contains P. So I would say segment Q, P, segment S, P, segment M, P. Those 3 segments. Name 4 lines that intersect line NK. Name 4 lines that intersect line NK. Well, here's line NK. Now we got to find 4 lines that hit that line segment or that line NK. Well, here's one. OK hits it right here. Here's one. And my pen's kind of freezing up, guys. Sorry about that. Here's one, and it hits NK right here. Here's one. It hits NK right here. Here's one, and it hits NK right here. So we're looking at, and by the way, if you want to call them line segments and not lines, that's fine with me. I don't care. It's not a big deal in this case. So line segment NQ, line segment KR, line segment KL, and line segment NM. Alright, all 4 of those are line segments that intersect NK. And lastly, name the intersection of planes KLM and QPM. Now, remember this from your notes, okay? When 2 planes intersect, they will always intersect. Let me rephrase that. When 2 planes intersect, their intersection will be a line. Their intersection, in other words, where the 2 planes intersect, their intersection will be a line. It will be a line. Okay, please don't forget that. So with that in mind, let's see what we have here. Name the intersection of planes KLM. So here's K, here's L, M, and then back up. So there's that plane. And QPM. So here's Q. Let's use a different color ink. Q, P, and M. And look at that. It goes over right there. Okay, do you see what line these 2 planes share? They share line NM. That means that's where they're intersecting at. So name the intersection of planes KLM and QPM. Well, look, here's the green plane, here's the red plane. They share this edge right here. So they intersect at segment or line, however you want to say it, NM. Segment NM. Okay, so what am I trying to teach you here? I'm trying to review with you what coplanar points are, collinear points, what a line is, a line segment, the intersection, what an intersection of 2 lines would be, what the intersection of 2 planes would be, just reviewing all these different terms, okay? That's what we're looking at here. Okay, let's go on to numbers 30 and 31. On numbers 30 and 31, we're working on a topic that we learned in chapter 1, and I think you guys found this pretty easy. It's called segment addition. Segment addition. And by the way, just because you sit and listen to me in class doesn't mean you've learned enough. You might have to go home and re-watch these or rework some of the problems that you struggle with, okay? That's where you have to know how strong or how weak you are with certain topics, okay? All right, here we go. Number 30. Sorry for yawning, excuse me. Find segment DF. Find segment DF. So from here all the way to here. Well, that should be pretty easy. I mean, we know from here to here we have a length of 8, and from here to here we have a length of 6. So the entire length all the way across of DF would be 14. And that's just called segment addition. All right, not too difficult. Now here is kind of the opposite. We know from here to here, this whole segment right here has a length of 12. We know the entire segment from here all the way to here, this entire length all the way across has a length of 30. And they want us to find the length of ST. Now think about it. What I have to do is I have to put a number here so that, let's put 18 here, so that when I take 12 plus 18, I get 30. And of course 12 plus 18 is 30. Now how do I know that it was 18? Well, students, think about it. If the whole entire segment is 30 and this much is 12, if you just take the entire segment 30 and subtract out 12, which is this segment here, you're going to be left over with this segment here, and 30 minus 12 is 18. So the length of ST would be 18, because 18 plus 12 is 30. So what I'm reviewing here with you is segment addition, okay? Or segment subtraction, where you add or subtract segments, okay? Now we're going to look at angle addition, or if you want to say angle subtraction, that's fine. But we're going to look now at some angle addition problems, okay? So let's take a look at these. Alright, now in these two problems here, let's start off with number 32. We're trying to find the measure of angle So the measure of angle STR. Well, let's highlight STR so we can see it. Here's S, and then we go to T, and then we go up to R. So we're trying to find the measurement of this space right here, this angle, okay? Now don't forget what you learned this year. We learned that whenever you have a straight line and a ray coming off of it or a line coming off of it, these two angles here, we'll call them X and Y, they will always add up to what? Do you remember? 180 degrees, okay? Because a straight line like this with a point always has an angle measurement of 180 degrees, okay? It's half of a circle. A circle has 360 degrees, so half of a circle would be 180 degrees, okay? So what we know is this angle right here, 110 degrees, this angle right here, and this angle here, we'll call it X. These two angles have to add up to 180 degrees. So that means this has to be 70, because if I take 180 and subtract out 110, I'm left with 70. So the measure of angle STR is 70 degrees. Not too bad. Okay? Now let's come over here. I want you to find the measure of angle DEF. So here's D. Let's go down to angle E, and then over to angle F. So I want you to find this measurement right here. Alright? Now, if you'll notice this, the entire measurement, now watch, from here all the way to here, that whole angle is 150. Angle CEF, that whole big angle is 150 degrees. Okay? And this little angle right here, I'm going to change colors and go red. This angle right here is 60 degrees. So if the whole angle is 150 and this much is 60, how do I find this little angle left over right here? Well, to me it's pretty much common sense. I'm going to take the entire angle, this whole angle 150 degrees, and I'm going to subtract out my 60 degrees, and I'm left with 90 degrees. So this angle right here is 90 degrees. And of course this angle right here is angle DEF. Angle DEF. So this is 90 degrees. Okay? So what are we going over here? Angle addition and angle subtraction. Okay? Alright, let's continue on. I believe this is the last problem. Alright, number 34. Number 34. Now, I remember very specifically when I gave this test, I was a little discouraged with the answers I got here. Okay? Let me show you something, please. If I have an array like this, and then an array like this, and then one like this, and I have these points right here, and let's call them X, Y, Z, and C. You cannot call this angle right here angle Y, because if you say look at angle Y, I'm going to have no idea if you're talking about this angle here or this angle here. Okay? And if you're talking about this angle here and you say angle Y, I'm going to have no idea whether you're talking about this angle here or this angle here or the whole entire angle. So when there's confusion like that, listen to me, you have to use 3 letters to name your angle, because sometimes there's confusion. For example, this angle right here, I would call that angle XYC, XYC, or I could call it angle CYX, CYX. But no matter what, the Y has to be in the middle. Okay? So I use 3 letters to name this angle right here. Now, if I wanted to name this angle right here, then I would call it angle ZYC or angle CYZ. But one thing I cannot do for the 3rd or 4th time is I cannot name any of these angles by just saying this right here. Hey, look at angle Y. You can't do that because angle Y could be this angle, it could be this angle, it could be the whole angle right here. I don't know. Okay? But look at the problem now that I've given you up here on your test. Look at this, please. There is no confusion. There's only 2 rays. Here's a ray, and here's a ray. There's no confusion. If I say look at angle B, you know exactly what I'm talking about. If I say look at angle B. So that's why I've asked you to give 3 names to this angle. First of all, if I say look at angle B, that's acceptable. That's fine, because you know there's only one angle that could be this angle here. Another name for this angle would be angle ABC. B has to be in the middle because B is the vertex. Do not call this angle BCA or BAC. Don't do that, okay? It's angle ABC, or you can call it angle CBA. Mr. Earhart, this is amazingly boring and a waste of time. Well, no, it's not, because we've had certain problems this year in chapters 4, 5, and 6 where we've had to talk about certain angles, and you had to be able to look at the notation and know exactly what angle we were talking about, okay? And that's why it was so important that we learned that in chapter 1, okay? Now, I'm not trying to make the video longer or shorter, whatever. I just want to very quickly, and I do mean very quickly, review. It'll take just a second here. You need to be able to make conjectures of patterns as to what will come next in a certain pattern of pictures. You need to be able to make a conjecture as to what number will come next when given a list of numbers. You need to be able to prove things wrong by giving counterexamples, okay? Look, I can bring 100 Siamese cats across the stage, 100 of them, and say, look, all cats are, how do you spell Siamese? S-I-M-E-S-E, I think. I'm not sure, actually. All cats are Siamese, okay? But just because I took 100 cats and put them across the stage and they were all Siamese doesn't mean that all cats are Siamese. All I have to do is bring one cat across the stage, just one that is not a Siamese cat. And as soon as I do that, I have given a counterexample that proves this wrong, that all cats are Siamese. And so that's what I'm trying to show you. You need to be able to give counterexamples. It only takes one counterexample to prove something wrong. I want you to know what points are, lines are, planes are, collinear points, coplanar points, intersection points, all of this stuff, okay? Be able to look at a diagram like this and answer questions about it. You need to know how to do segment addition, segment subtraction, where you add two segments together, or you take a big segment and subtract out a smaller segment. Same thing with your angles, no angle addition, angle subtraction, be able to do all of that, okay? Moving on to number 34, be able to give three names to an angle and know when you cannot do that. Okay, on the test I might try to trick you and give you a problem like this and then ask you, can you call this angle right here angle C? And no, you could not, because there's confusion here as to which angle I will be referring to. So know all of that information, okay? I hope this is a help to you. I had a student yesterday email me about some mistakes I had made on their test. They did a really creative thing. They took a picture of their test. I could see they had not added or changed their test. I had written things in red and crossed things off, and so they contacted me, and we're going to get that fixed. So if you have any questions, any comments, email me, call me, whatever, get in touch with me, and I will help you. Okay, have a good rest of the day, and I will talk with you guys tomorrow.